Okay, this is for ADT and problem solving on stack. Okay, for the stack, we will learn the concept of the stack with this leave for last in first out. As you see here is the how stack work. So we will put something together like a stack, and then we would like to get this tray. So what you need to get is you would like to get the top one, right? So this means that the one that last in the top that put in the stack will be the one that first out. Okay, so this is how stack work, and they will have some information that need to use the stack to help solving the problem. This is one of the ADT structure. So the operation of the stack, we're gonna have like push, pop, and peek. Push is to insert. Okay, insert the tray or anything like pennies, boxed, or a shirt to the stack. Pop is to remove or return the pop item. So we pop out mean that we will return that top one out, right? And peek will be like point to the top of the item without removing it, just point where it is. Okay, and the operation is will be just on. Then let's see the pseudocode for the ADT. One is you can create a stack, check that is this empty or not, and you can push it by adding things into the stack on the top, right? Pop is just pop the top one out of the stack and return the top one. Pop all, so they will like pop all the item from the stack. Peek, so they will point to the top of the stack. Okay, let's see, here is an example that we will use the implementation of the ADT stack from like LA linked list, ADT list, and you can see that how we can like create a stack by LA itself and use the pointer point to each position and then point out that that is the top one or the second, third, or noun. And we can also use linked list to show that this is the top node, second node, third node. Okay. Here it's just the example that we will have the stack, create as a stack, name as T, and then you will use operation push 6. So 6 here, and then top is at 0 position, and push 1, top is as 1 position. To push 7, push 8. Right now top is as 3. Okay, so if you like to ask that the index of the top is, we will calculate by using the current size. Size right now here is 4, so this will be 4 minus 1, right, which will equal to the position of the top. So it is actually the same thing as the index, right, in the LA. When we popped, we don't have to declare the value here inside, but they will pop the top one out, and then the program will return the numbers here, which is 8, right? So they will return 8 out, and then the position will moving down, top position will moving down. So here is some example that we try to push the number into the stack, like name as 1, then we push 1 2 3. So we have the stack, and then the first one is coming in, which is 1 2 3 9 5 6 and 89. And then what we're gonna do is we would like to check, right, that whether stack is empty or not. So what we're gonna do is just S1 is empty or not. Then the pointer, the top one is point at position 0 1 2, right? So it is not empty. When it's empty, it's supposed to point at this position, and the return value is -1. And then we will show like what is S1 peak. So they will go to the top value, and then they will return 89, right, which is the peak of the stack. And then the element removed from the stack when we use pop, S1 pop. So the first one or the top one will be pop out first, which is 89. So the return value is 89, of course, right? And then they ask what is the remaining stack inside. So we here just only have what 1, 2, 3, and 9, 5, 6. And then when we shake the element by using stack search, for example, we would like to search for 56, and here there is no 56 in the stack. The value they're gonna return is -1, just that. So here is the example of the code for the Java stack. And another application that we can use for the stack is for the banquet here. That is this balance or unbalanced. Unbalanced mean they open and they didn't close. Then how we can use stack to solve this graph problem. So here is a pseudo code. Okay, let me call this one as open and let me call this one as closed. So when we see the open bracket, then the stack will be collect this one, like we will push it into the stack, okay, and we will scan this string until we found the closed one. Once we found the closed one, we will pop it, right? We will pop it, and then the condition we're gonna check that this is the empty stack or not is at last, after we scan all of this one and there is no more things left inside the stack, means that they have already opened and closed, means that the number of the blanks is balanced. So when it's empty, means it's balanced. But if they have something left here or still cannot close it, like cannot pop it out, then it means that it's still imbalanced based on this condition. Okay. So here's how we can check. So this will be the formula, the coding that we check for open and closed. Same here if we have more than one type of the characters for the parentheses. Okay. Here is showing how we move the pointers. When it's empty, they will start at -1, and when you add the value, they will going up like this, up and up. So the top value will represent this position. So in the max size is 6. So this means that when it grow up to this position, means this is the maximum capacity of this stack, right? Another thing that we're gonna check is checking that is this empty or not. So if top is not equal to -1 here, then it's not empty for sure. And another one is checking that it's full or not. So if it is full, so it means that the top position is supposed to equal to 5, right? 5 is come from max size -1. So if this is point here, so they have some value here and value here. So it means that this stack is already full. This is how we write an algorithm to track that is this empty or is this full. And we can also use this one to play with the top plus top and minus top for the pop, peak, and push. Okay, when you would like to pop, so you need to go through the position that you would like to pop, right? And then it will reduce 1. So we pop first at that position, and then the top will be reduced from 3 to 2, for example. Peak, so at that position they will represent that value, which is also 20. Push, so it means that they need to go up 1 position, which is have to be +1 first. 2 plus 1 equal to 3. Then we point out at this position and just add the value. So this is how it works when we use the stack array to do for the ADT stack. Alright, easy. And here is some example that we can use, like the undo button, okay, back button, something that we like to have to go back and forth. We like to go back to the previous positions. Or you can use this to solve the problem of the like prefix, postfix, infix. Okay, and somehow it's like why we need to change all of this equations into the prefix or postfix, because somehow it is easier for machine to use the stack and also fast in the operators when we do it in that way. Okay, let's see how it's works. For here is to evaluate the prefix expression. So what we're gonna do is we're gonna scan from the right to the left. So we're gonna scan from the right to the left. The right one is start from D, so we push D in the stack. Second one is C, and then we see the operations, so we'll do some operation and get the conclusion here. And we add B, add A, and some operations. When we have the operation, we're gonna have the last operation here. Then we will get the solutions. That will be the calculation of the prefixed expressions. But remember that I have to start from the right to the left. Okay. Postfix. Okay, if you would like to evaluate the postfix expressions, so you can see that we'll push each number into the stack, like start from 7, 4, 3, and then multiplications. For the multiplication, will be multiply these two together, and we will get this number, right? And then what else? We add 1, add 5, and plus is this 2. So it's become 6 here, and rewind. So as well, rewind 6 and 12, and then we become minus 2 here from this 2, and then multiplication. So we'll multiply these two numbers equal to 14 minus 14 here. This is the way we use the stack to calculate the postfix expressions. Here is for the large number calculations. So what we have to do, okay, let's look at this one first. When we do the calculation, actually we have to start from the last position first, right? So if you like to do the last position first, it means that the last position have to be on the top. Am I correct? Yes. Okay, so it means that the last position has to be on the top of the stack, because we would like to calculate it first. So we will pop 2 and 4, and then plus is at 6, and we get the solutions here. 6 will be here. Okay, there's no carry out, no carry in. So we will pop the second unit, which is 9, 8. 9, 8 is equal to 17. So 7, put it here, and 1 is carry into the next position, next digit. And then carry in means you need to plus 1 here as well after you pop 5. So you have 5 and 7. 5 and 7 is 12, and then it's become 13. And then the last unit, you put it here in the stack, and the carry out here become the carry into the next position. 1 plus 3 is 4, and 4 put on the top of the stack, and this is the solutions. Okay, that's all.